Those interested in learning something interesting about the LRO images. Many will ask what could be interesting in this well-worn question. But still, take a look, there's a new one. I'll start with the well-known fact that the LRO satellite was designed to solve many new and very important tasks, which, according to NASA, it accomplished with excellence. Understanding this, one should be cautious about critics' accusations about the poor quality of LRO images, Apollo landing sites, and Soviet stations, by modern standards. Therefore, I decided to test the critics' conclusions. As a rule, critics compare LRO images with images of known Earth satellites. Let's take, for example, the World 2 satellite, launched in 2009, as a basis for the LRO image. Its orbit is at an altitude of 770 kilometers, but it carries a telescope mirror with a diameter of 110 centimeters and a focal length of a whopping 13 meters. Such a thing, of course, wouldn't fit on the LRO satellite. LRO has 3 cameras, but we're only interested in the one with the highest magnification, the narrow-angle camera. It consists of 2 identical cameras to produce stereo anaglyph images. These cameras are equipped with relatively modest telescopes. The mirror diameter is 20 centimeters, and the focal length is only 70 centimeters. Nevertheless, flying at an altitude of just 21 kilometers above the moon, we're promised almost the same half-meter per pixel resolution in black and white as the expensive View 2. This is realistic. However, here's an example of a photo from Volt View 2. Let's try combining a photo from LRO and View 2 at the same scale in one frame. Here's what it looks like. It turns out that the image from View 2, while not catastrophically so, actually looks better than the URO, and it's in color too. Let's take another Earth satellite, GeoEye-1. It has a telescope almost identical to World View 2, and the pixel resolution is also about half a meter. We compare and see a very similar difference. How so? It turns out that if we were presented with images of the moon with the same quality as these Earth satellites, we would probably be quite satisfied. In other words, the pixel resolution was chosen correctly for RO. But instead of the rover and lander, we see only illegible spots. Perhaps the pixel resolution of the LRO cameras and telescope is actually worse than half a meter. Or perhaps the capabilities of the LRO cameras are somehow underutilized. However, both possibilities seem unlikely. Parameters are parameters, so let's look for other explanations. Indeed, if you look closely, the quality of the LRO image of the moon's surface is quite acceptable. The tracks of the rover and the astronauts are perfectly captured, but only the things that primarily attract our attention are poorly captured. That is, as luck would have it, only the lander and rover left on the moon. So the possible conclusion is this: the critics are not entirely correct, the pixels are fine. Only the most interesting parts of the images don't match the pixels, and that's alarming. The shape of the lander's shadow is even more puzzling. Let's zoom in on this section of the RO image and compare the image to the size of the lander. It's clear that the lander's shadow doesn't follow the contours of the lander, but rather encircles it. The sun is clearly high above the horizon. But looking at the shadows in the craters, you wouldn't know it. The shadows are much more similar to those taken with the sun at a relatively low angle. I decided to take a closer look at the question of what kind of shadows the craters should have. First, I needed to determine the slope angle of the lunar craters. I was only able to determine the exact slope angle for the crater near the Apollo 12 landing site. There, the crater had a slope of about 10 degrees. For Apollo 16, I couldn't find a suitable image of the crater near the module, so I combined 5 official overview images to create a panorama of the crater near the Apollo 16 lander. The crater's appearance suggests a tilt of approximately 12 degrees. I made paper models of 4 craters with tilts of 12, 15, 21, and 30 degrees. To prevent the edges of the models from bending, I glued them to holes in a sheet of argillite, and reinforced the argillite with a rod. I installed pins on the sheet along the length of the shadows, which can be used to measure the angular elevation of the illuminator in degrees. We see that when the sun is low, the shadows are parabolic in shape, narrowing as the sun rises or as the crater depth decreases. When the sun rises at an angle greater than the crater's tilt, the shadow takes on a blurred outline, and when the sun is higher, it almost disappears altogether. Taking all this into account, we can already estimate the solar elevation in the LRO images. Here's another LRO image, which, for some reason, has lower pixel resolution. Let's crop out the portion corresponding to the previous image and combine the two images. What do we see? There are no hills in the images, only craters. The shadows are all facing the same direction. Even the rocks are barely visible, which is actually strange if footprints are visible. In the right image, no traces of the rover or astronauts are visible, but the module is there. The length of the module's shadow in the right image is 28 meters. With a module height of 3.3 meters, this corresponds to a solar angle of 6.5 degrees above the horizon. The sun is in the west. The shadow is close to the crater module. It doesn't correspond to its 12-degree tilt, but rather to 20 degrees, which is impossible. The crater is not at all deep. There is even indirect evidence of a 10-degree tilt. After all, if the crater had been 20 degrees, there would have been a risk of the module tipping over during landing. This would certainly have been mentioned. In the image on the right, the shadow of the module's remnant is long, while the rover's shadow remains short. The shadows of the instruments and the instruments themselves are not drawn at all. In the image on the left, these two craters have identical shadows, meaning they have the same slope angle. Crater 2 is darker, meaning it is deeper. And in the image on the right, craters 2 and 3 have a shadow shape corresponding to a shallower depth than crater 1, which is closest to the module. This means that the shape of the shadow on crater 0 is drawn incorrectly. I deliberately said drawn because it simply couldn't be otherwise. With a high sun, according to the shape of the module's shadow in the image on the left, the shadows on the craters should be almost absent, but they are clearly visible, which is only possible with a low sun. It's possible to achieve more contrasting shadows by processing the images, for example, by significantly reducing the brightness, but then the image would lack bright spots, and that's not possible. The module's shadow would then be long, but it's drawn short. Here's another little-known LRO image of the same location. From the module's perspective, the sun is close to the zenith and to the west, but the shadows in the craters correspond to the sun's low position. According to my images, it's no higher than 25 degrees. The resolution of this image isn't very high, but unlike image 2, all the traces are clearly visible. Even traces that aren't visible in a much higher quality image are revealed. Again, the conclusion is the same. The image has been retouched. Therefore, all three LRO images have been retouched and processed. The first and third images are superimposed on images of the moon, the rover's tracks, and the astronauts. All the images are overlaid with blurry, fuzzy images of the module and rover, along with their shadows. This is clearly a fake, designed to perpetuate the lunar landing hoax. It logically follows from the fact that I have already proven it to be a fake, the only video of the rover driving on the supposed moon. Nevertheless, let's continue examining the images. Here's a video of Apollo 16's launch from the moon, which shows the abandoned portion of the lunar module and the surrounding terrain. The video was taken back in 1972. I chose a good frame, then rotated and cropped the first photo of the lunar module we looked at for easy comparison. Let's compare. It's easy to see that all the landmarks on the ground match exactly, including the tire tracks of the rover and the astronauts themselves. This is impressive. Well, here's what I suddenly noticed. The images not only match, but even the shapes of the shadows, hills, and craters match exactly. This is strange, to say the least. So I decided to look at LRO's photographs for other missions, and then I came across an article online that was important to me. It turns out I wasn't the first to rotate and crop the LRO photograph to make it easier to compare with the launch video footage. Here's another similar comparison for Apollo 14. The author of the article claims that such detailed lunar terrain features as those in the Apollo 14 video were unknown to anyone. Therefore, in his opinion, they are 100% proof of Orion's landing on the moon. After all, such a forgery is logically impossible. After all, you can't fake something that's still unknown. But then, what was the landing in an unknown location? Too risky, so I decided to check whether the terrain was truly unknown. And indeed, the author clearly got carried away and was mistaken. There was no unknown location. Here's a picture taken by the Lunar Orbiter 3 satellite. It was flying to find a landing site for Apollo 12. The picture is of good quality. It looks no worse than that of the Lunar Orbiter, although its camera parameters are only half the size of the Lunar Orbiter in pixel size. Of course, similar pictures were taken for all subsequent Apollo missions. There were 5 lunar orbiters. They not only searched for landing sites but also measured radiation, gravitational fields, and other things. It turns out that after 40 years of progress, the cameras and telescopes of the Lunar Orbiter 3 satellite have barely improved in pixel resolution compared to those of the Lunar Orbiter 3. That's truly a surprise. Thanks to the author of this article for raising this point, and especially thanks for providing the materials comparing the Lunar Orbiter pictures with the video footage of the Apollo 14, 15, and 17 launches. I must admit, when I saw these duplicate images, I was truly stunned. In all pairs of images, the shadow shapes for all objects are completely identical. Thus, chance is unlikely here, and one gets the impression that this coincidence was forced. Why unlikely? Because the day on the moon is long. It's almost a month on Earth. And to choose the right moment to take a photo with identical shadows, you have to orbit for a very long time and wait. But why? There's no need for that. Besides, over the past 40 years, the lunar terrain should have changed at least slightly, and yet in all pairs of images, the shadows are completely identical. So, 4 times in a row. This is pure science fiction. Everything matches up down to the smallest detail, even what could be mistaken for a frame defect. At this point, I began to seriously ponder how such a miracle could have happened, and all sorts of crazy thoughts crept into my head. Do such landing sites even exist on the moon? What if all the photographs of these places are nothing more than stage designs on Earth, simulating lunar conditions? There was simply nothing for this LRO to photograph. On the moon, he didn't put much effort into it. They just retouched old photos and pasted them into new ones. If you're going to lie, do it big. Scenery from other times of the lunar day could also be captured and pasted into real lunar photos. But here I realized I was breaking my own rules. Don't dress up mere fantasies as real research. So, at this interesting point, I'll say goodbye for now. Thank you for your attention. Until next time on YouTube.